Welcome to City and Guild's Math and English Skills session. Thanks for joining us. I am Tamika Lodge-Fenton, and I'll be guiding you through today's math lesson. We'll be focusing on ratio and proportion. Let's begin. The unit we're looking at is ratio and proportion, and the aim of this unit is to develop skills in reading and using scales, ratio and proportion. For this session, you'll be able to use inverse and direct proportion to solve real-life problems. Before we get into the whole lesson content today, we have a few things that we just want to make sure you are fully aware of. What is a ratio? Ratios pretty much compare values. Proportions compare ratios. All right, so a proportion is simply a statement that says two ratios are equal. It can be written in two ways, as equal fractions. So we have A all over B equals C all over D, or using a colon. So we have A to B is equal to C to D. The following proportion is read as 20 is to 25, as 4 is to 5. Types of proportion. We have direct proportion. When two quantities are so related that an increase in one causes a corresponding increase in the other, it is called direct proportion. Then we have inverse proportion. When two quantities are so related that an increase in one causes a corresponding decrease in the other, it is called inverse proportion. So the two types of proportion that we're looking at is direct, where as one increases, the other increases, or as one decreases, the other decreases. Then we have inverse proportion. One is increasing while one is decreasing, and obviously one is decreasing, one is increasing. So they're going in opposite direction. So we'll start off with our inverse proportion. Let us look at these two examples. It takes 4 men 10 days to build a brick wall. How many days will it take 20 men? So let's reason this out, guys. You had 4 men, it took 10 days. You have way more manpower now. You have 20 men. Clearly, the time to build this brick wall once everybody's doing their work is going to take less. So, as the number of men increases, the time to build the wall will decrease. That's an example of inverse proportion. Another one. So you have 4 people can paint a fence in 3 hours. However, what if I made, I got 2 more persons to help, so now I have 6 persons painting the wall. It must take less time. So this is another example of inverse proportion, because as the number of people increase, the time it takes to paint the wall will decrease. All right? Then we have another one. Let's work this one together. If it takes 2 hours for 4 workers to complete a job, how long will it take 8 workers to complete the job? Now let's look at the ratios that we have. So remember when we did ratio before, we always state that the order matters. So we said 2 hours first in the question for 4 workers. So as you can see, the ratio is 2 to 4. Now, as the number of men increase, the hours will decrease, because we know that if you have more manpower, you're going to definitely have less time. So we have 2 ratios there. We have 2 to 4 and the unknown time to the 8 workers. What do? We look for the relationship. So we're just going to go on the board quickly. If we have the ratio 2 to 4, and now we have, so we know the time was 2 hours to 4 men. We have X hours. So I'm just going to put hours to workers here, so we know what we're dealing with. All right, and we know that we have increased the number of men to 8. What do we do here? We can examine the two same parts of the ratio, so 4 to 8. What would have happened to 4 to get it to 8? It would have been doubled. So I would have multiplied it by 2. Now with inverse proportion, you can look at this relation and know how to treat this one. So if this would have been doubled, we clearly would have half this. So we can either divide by 2, or I'm going to put it out here. We could multiply by a half, which is the same, and half of 2 is 1. And we know that 4 times 2 is 8. So really and truly what we're saying, 8 men, 1 hour. So it's 1 hour to 8 men. So if the number of workers would have increased by doubled, that means the time it took to complete the job would have decreased by the same half. Half is the same as multiplying by 2. All right, multiplying by half is the same as, yes. All right, so we have here, we have 2 is divided by 2, and you have 4 being multiplied by 2. So you have 1 hour to 8 workers, and that would have been that. All right, so we have a speed, we have speed time. Let us look a little bit at speed, because it's required for the next question. Speed and travel time are inversely proportional. Now, think about it. The faster you're going, the more distance you're going to cover, right? So the less time it takes to reach somewhere. So if you are traveling at 50 kilometers per hour to go somewhere, if you step on the gas and you go to 80, you're going to reach there faster. Right, so speed and travel time are inversely proportional because, for example, the faster a car goes, the shorter the time it takes to travel certain distance. All right? So as speed goes up, travel time goes down, and as speed goes down, travel time goes up. So here we have an example here, or a scenario. A journey takes 4 hours at 30 kilometers per hour. How long does it take at 50 kilometers per hour? So before we even start the question, let's think about it. The journey takes 4 hours. We don't know the distance, but it takes 4 hours if the person is traveling 30 kilometers per hour. How long will it take if someone else is traveling 50 kilometers per hour? So one is traveling faster. Clearly, the time is going to be less. So let's work it out. So we have some information here. Speed is equal to the distance divided by the time. All right, so we know the speed, we know the time it took, but we are unaware of the distance. So we can definitely transpose and find it. So here we go. So we can determine the distance by substituting all the values we have and transposing and making distance the subject of that equation. All right, or we can call it the math sentence. All right, so we have here the distance is equal to the speed multiplied by the time. So we have 30 kilometers per hour multiplied by 4 hours, giving us 120 kilometers. So the distance that we're looking at is 120 kilometers. Now, we're asked to find out what would be the time if the speed changed. Let's look at that. So we can now form a new equation because we now have a different speed, which is 50 kilometers per hour. We know the distance. We do not know the time. That's what we're trying to find out. So let us transpose for time. So here I would have done it a little bit different here. So I can rewrite it where I have the speed multiplied by the time giving me the distance. I want time to be the subject. So I divide throughout by 50 because time is equal to distance divided by speed. And that would give me 2.4 hours or 2 hours and 24 minutes. Now I know some of you might be wondering how we get that 24 minutes. So let's just do it on the board so that everyone understands. So when you divide 50 by, 120 by 50, you're going to get 2.4. But you have to remember hours. So 2.4, let's write this as a fraction. So 2.4 can also be written as 2 and 4 tenths. And of course, we know we could simplify it. But for this use, we're going to keep it at 4 tenths. So this is 2 hours and 4 tenths of an hour. How many minutes are in an hour? So we know that 1 hour is made up of 60 minutes. Great. So if we want to find what is 4/10 of an hour, we're going to have to multiply it by 60. So let's do that. Simplify wherever possible. 10 into 10 one time, 10 into 60 6 times. 6 fours is 24. So what we're saying, 4/10 of an hour is 24 minutes. So if we have 2 and 4/10 hour, it is equivalent to 2 hours and 24 minutes. All right. So let's move on to the next question. Or, well, this is just information. Let's look at it. So we were looking at inverse proportion scenarios. Let us look at this particular diagram now. We have hours worked and we have salary. As you can see, the 1 hour is lined up with the $20, 2 hours, $40, 3 hours, $60, 4 hours, $80. As you can see, as the hours increase, the salary is also increasing. Therefore, you should know that this is direct proportion. As one part of the ratio increases, the other also increases. All right, so let us look a little at direct proportion. In a recipe, the ratio of weight of flour in grams to number of eggs is 300 to 2. All right. Now, if you use 6 eggs, how much flour do you need? All right, so what's the ratio we have there? And I want to draw your attention to some key points in this question. You have the recipe, the ratio of weight to flour in grams to number of eggs. So remember, when you're looking at ratio, the order matters. The question mentioned the flour first. So the value within the ratio, which is 300, must be referring to the flour. And it did say flour in grams, and then it went to say number of eggs. So this is 300 grams to 2 eggs. The question then says, if I use 6 eggs, so what we're doing now, we are changing. We're looking at another ratio. 6 eggs, how much flour will we use? We don't know. But we can look at the relationship with the number of eggs that was used first to the number of eggs that is going to be used next. What 2 divided into 6 goes 3 times. So that means if I multiply 2 by 3, I would get 6. So this is being times by 3. So this here has to also be increased by 3. So let's do that. So 300 multiplied by 3 is 900. So what we're saying, and I'm just going to put these in. So we have 900 grams to 6 eggs. So if I were to increase the number of eggs to 6, the flour would also have to be increased to 900 because this is directly proportional. If you are baking something, if you increase one ingredient, you clearly have to increase another because the recipe would call for more. All right, so here we go. It's 900 grams of flour to 6 eggs. All right, guys, we are going to look at some City and Guilds questions at this time. So the first question for the afternoon. It takes 8 hours for 3 workers to complete a job. How long will it take 6 workers to complete the job? So now we have, with the first scenario, we had 8 hours to 3 workers. And you can definitely, when you're working your problem, guys, write your ratios as you see them. It helps to have an understanding. So let us look. We have 8 hours. And you can put in the categories or the type of quantity, the numerical quantity you're referring to. So you have 8 hours to 3 workers. So that ratio would be 8 to 3. It says, how long would it take if you had 6 workers to complete the job? So workers, you put the 6 on that side. You are trying to determine the time it will take 6 workers. Now, right away, you should realize that there is what relationship between 3 and 6? 3 is being doubled. Now, we know that this, just thinking about it, if you have more workers, you can't double the time. That don't make any sense, does it? No. So you're going to have to figure out how you're going to figure what would have happened to the number of hours. Remember I said, when one is increasing, the other is decreasing. So I would have multiplied by 2 to get my 6. What's the opposite of multiplication? It is division. So I am decreasing it. So I'm cutting it by the same 3. So let me write this small because it looks a bit too big for me. All right. So what happens there now? Why am I writing 3, guys? It's 2. Right. So there you go. So 8 divided by 2 is 4. And you have 6. So you have 4 hours to 6 workers. And think about it. If you had 3 workers and you have 8 hours, now you double the number of workers. Clearly, the time it takes is going to be cut in half. So 4 hours, and you can put in your hours and your workers, and you're done. It's a simple problem. I think I worked it the same way there. So we have X hours, so the hours would be halved. And 8 divided by 2, 3 multiplied by 2 gives us 4, 6. 4 hours will be the decreased time if the workers increase to 6 workers. All right, and you should choose the correct option there. Next question. A journey takes 2.5 hours, 2 hours and 5/10 of an hour to an average speed of 50 kilometers per hour. Now, how long will the journey take? If you are traveling at 30 kilometers per hour, let us see. So the speed equal distance divided by time, we know this. Distance is equal to speed multiplied by time. We have the speed, we have the time. 50 multiplied by 2.5 gives us 125 kilometers. So we now have the distance. We can substitute this into a new equation because we now have a different speed working with. So 125 is equal to 30 multiplied by the time. We need to find the time. So we transpose for the time, of course. Time is equal to 125 divided by 30, which gives us 4 and 1/6 hour. Now let's look at the option. You have 2 hours, you have just over 3 hours, you have just over 4 hours, and about 6 hours. Clearly, you must realize that it's choice C because it's just over 4 hours. So those are things that you need to pay attention to. All right, guys, you know what? It's that time of day when our lesson has come to an end. That's our math lesson for today. I hope you have learned a lot. And as usual, it was a pleasure guiding you through.